We're going to talk about how to apply the factor theorem to examine a factor and whether or not it's a factor of a polynomial. So we have a polynomial here, p of x equals x to the fourth minus 3x cubed plus 4x squared plus 5x minus 3. It's a big polynomial. It's a quartic. It goes up to the fourth power. But how can we determine whether or not x plus 1 is a factor of this polynomial? Well, the way to do this is we have x plus 1 here. And remember, our factors are x minus our factor, so this is actually a negative 1. We're looking to see if that is a 0 of the function. So the way we do that is we put our 0 in for x in the polynomial, and if it equals 0, then that's a 0, and this is a factor. So if our factor is x plus 1, we're going to plug negative 1 into p of x. So we have p of negative 1 equals negative 1 to the fourth minus 3 times negative 1 cubed plus 4 times negative 1 squared, plus 5 times negative 1 minus 3. And when you solve all this and simplify it, we find that p of negative 1 equals 0, so x plus 1 is a factor. But if we change our a value, our 0, what we're looking at here, let's change it to something different like 3. We're now going to look to see if x minus 3 is a factor, or if positive 3 is a 0. So we plug positive 3 into p of x, and we basically substitute every x for 3, and we find that p of 3 equals 48, not 0. So x minus 3 is not a factor, and you can play around with different polynomial equations, different a values, look to see if different things are factors, and basically the way you tell if something is a factor is you take this a value, so remember this is x minus a, that's crucial. So if you have x plus 4, we're going to use negative 4. If you have x minus 4, we're going to use positive 4. You plug that in for x into your polynomial equation, and if that equals 0, then what you had is a factor. If it does not equal 0, it is not a factor.